Our project is called Maze Runner, and what it does is it creates a graph-based maze comprised of adjacency lists. There are two main aspects of our project. The first is visualization, where upon selecting one of these four algorithms, it will create an animation so the user can see how each algorithm functions. The second aspect is the data aspect. Upon clicking time in comparison, the user will be able to input the length and width, and then it will run all these algorithms and display certain data about it.
All right, so this is the visualization section. Michael is just going to run the four algorithms in the background so you can see what they do. But basically, we can't exactly fit a 100,000 node graph into a screen. So we slimmed it down a little bit into one that fits in a window like this, and you can actually comprehend what's going on. But basically, it just runs the algorithms with the light green path, and it shows once it hits the end, it does the dark green path for the actual shortest path. The way this was actually generated, though, the maze it's a modified version of DFS, depth first search. It runs that, and that makes a maze with one answer. However, most of these are shortest path algorithms, so we need more than one answer because we want the shortest path, obviously. So then after we do that, we randomly knock out a couple walls, which are actually edges because we're using a graph. And that's what you're left with here. This is A-star algorithm. It's a version of Dijkstra with a heuristic function to help guide it almost. So it's a little bit faster than Dijkstra's. And that's pretty much it.
There are two more features I'll mention. There's a reset button. So if you want to run the algorithms again, you can do that. There's also the new maze, which just generates a new maze. So now if we click time in comparison, using the up arrow or the down arrow, we can control the side length of the graph we want, of the maze we want to create. So I'm going to run it with 1,000,000 vertices just for fun. And then we're going to see how long it takes and other information. So this has 1,016,064 vertices. So you can see DFS took 1.5 seconds, visited this many vertices, and the final valid path is this many. We also see the same for BFS, Dijkstra's, and A-star. There's a few important things you want to note. For A-star, Dijkstra's, and BFS, the shortest path will all have the same amount of vertices because these are shortest path algorithms. DFS is not a shortest path algorithm, so it just returns the first valid path. Another very interesting thing is A-star will consistently visit less nodes than Dijkstra's. And we can run this as many times as we want. Let's say we want 100,000 vertices. We could do the same, and then we have the information there. And we could even make it, as small as we want. If we run it with this many. Yep. Another important thing to mention is that we created this project using only C++ and the SFML library.
Yeah, all in all, this is just a easy tool to compare these four algorithms. You can visualize, you can do timing for whatever size you want. It's just a handy tool for learning about graph algorithms.